Hello everyone, myself Kirti, along with my teammates Munaza and Yeshita, currently pursuing BTech in Information Technology from Gokaraju Rangaraju Institute of Engineering and Technology. I would like to share our project, an efficient novel approach on IoT, enable intelligence stick for visually impaired people through GPS module and ultrasonic sensor that is based on Internet of Things, which is done under the guidance of Y. Subbaraidu sir, assistant professor. Now let's get into the project. In world, visually impaired people face many difficulties in performing their day-to-day activities, mainly in traveling, for which they have to depend on others. Our project tries to resolve their problems and give better understanding of surroundings to the person, and it also provides monitoring facility to the caretaker. Presently, there exists a white cane and a smart cane which helps the blind person to do their activities but doesn't give the complete information of the surroundings. Our project consists of an ESP32 board associated with many sensors like ultrasonic sensor which measures the distance between obstacle and sensor, soil moisture sensor which measures the soil moisture of a particular place, and a GPS module that gives the current location of blind person along with a buzzer that alerts the person when the moisture and distance exceed certain limit. It is also associated with Firebase that stores the location information of the blind person and a mobile app through which the caretaker can access the location of blind person, thus providing a feel of safety to the blind person. And here comes the hardware and software requirements. The hardware requirements are an ESP32 board, ultrasonic sensor, soil moisture sensor, buzzer, GPS module, etc. And software requirements like Arduino IDE, mobile app, and cloud service. This is the use case diagram, sequence diagram, and state activity diagram, data flow diagram. Here comes the architecture diagram. Firstly, the sensors collect the data of environment like distance and soil moisture. Then the data gets processed at boot. If the data exceeds the threshold, then the buzzer alerts the person and the location of the person accessed through GPS module gets stored in cloud. From there, the person can access it through Cordler app. Let's have a look at the code. First, import all the required libraries. Here, Firebase ESP32.h is imported to access the Firebase. Software serial.h is a library for enabling the serial monitor. Tiny gps++.h is for accessing the GPS module, and these are the initialization of pins, and this is for setting of the pins, and this part of the code is for reading the input from ultrasonic sensor. This part is for reading the input from soil moisture sensor, and this part makes the buzzer to turn on when the distance is less than 50 centimeters and soil moisture exceeds the limit of 1500. Latitude and longitude values of a GPS module. This is for enabling the Wi-Fi, and this is for enabling the Firebase, and this part of code writes the data into the Firebase. Now let's have a look at the Cordler app. This is the design of the Cordler app, and this is the block diagram. Let's have a look at the execution. This is the setup of the project. The code is getting uploaded into the board, and when there is no obstacle detected or soil moisture detected, the buzzer turns off. On the serial monitor, we can see the distance, soil moisture values along with buzzer status and the latitude and longitude of the person. When there is an obstacle detection or a soil moisture detection, the buzzer gets turned on. This is the GPS module, and the location of the person gets updated in the Firebase as the person moves. This is the Cordler app, Cordler design, and it is getting uploaded to the phone through the scanner. Here we can access the person's location through the mobile application. This project was done under the guidance of Y. Subbarayadu, sir, Assistant Professor, Department of Information Technology. Thank you.